Okay, part A, you have to find the values of A, B, and C. Well, B and C, and show that A is equal to 0. So I'll just go through this just so we've got the whole question sorted. So the first thing, you need to imagine bringing the right-hand side to the common denominator, and then you're going to have the same denominator on the right-hand side as on the left-hand side, and therefore you'll be able to compare the numerators, because that's the only way the two fractions will be equal. Alternatively, you might think of that as multiplying the right-hand side through by the denominator on the left-hand side, okay? But I'm just going to imagine I'm multiplying it, bringing it to the common denominator. So the common denominator is going to be this denominator on the left-hand side. So the first fraction needs to be multiplied by 3x plus 2 in order to have 3x plus 2 squared, and then by 1 minus x. So A will be multiplied by 3x plus 2 and 1 minus x. Then the second fraction already has two of these brackets, so you just need to multiply it by 1 minus x. So you do the same to the numerator. And the last one needs to be multiplied by 3x plus 2 all squared, 3x plus 2 all squared. There you go. So now the numerator of that fractions, if you were to combine them together, would be 3a times 3x plus 2 times 1 minus x, then b multiplied by 1 minus x, and then c multiplied by 3x plus 2 squared. And that has to be equal to 27x squared plus 32x plus 16. Okay, now you've got to make each of those brackets disappear, so you just be able to work out the values of some of the letters at least. So the first value that we're going to use for x is x equals to, if you make this one equal to 0, minus 2/3. We're going to substitute minus 2/3 into the left-hand side of this fraction. The best way to do it really quickly is to put minus 3/2 into the calculator. So minus 3/2, and use the ands key to substitute it into the left-hand side. So we've got 27 ands squared plus 32 ands plus 16. So that's 115/4. Just check. Apologies, I should have put minus 2/3. So minus 2/3. I've put 3/2. Just scroll up, that's not a problem. So it's 20/3. Okay. Right, if you substitute minus 2/3 into this bracket, that will make it equal to 0. So you have 8 times 0 times something else, so that will give you 0. If you substitute it into this one, you will have 1 minus minus 2/3, so that's going to be 5/3 of b, and then this one again will go to 0. So this way you've got 5/3 of b is equal to 20/3. So if you divide 20/3 by 5/3, you will get 4. Okay, the next value you're going to substitute is 1. If you put 1 into this left-hand side, you'll have 27 add 32 add 16. If you put 1 into this, that will go to 0. This one will go to 0, so you just have to put 1 into the last part. So it's c multiplied by 5 squared. So this is going to be 20, 60, 70, 60, 75. Yeah. 75 is equal to 25c, giving us c is equal to 3. So you've got the value of b, you've got the value of c. Now we need to find the value of a. So we've run out of values that make those brackets equal to 0. So what you need to do is try another value of x. So let's try x equals 0. So if you can try 0, because it makes the calculation easy, that will go to 0 plus 0 plus 16, so 16. On the right hand side you have a times 2 times 1, so it's 2a because x is 0. Here b times 1, and here you have c times 0 plus 2 squared, so it's going to give you 4c. Now we've got the values of b and the values of c, so let's substitute it. So you've got 2a plus 4 times 3 is equal to 16, so 2a plus 12 and 16 is equal to 16, giving us 2a is 0, so a is 0. We've shown that. There you go. So that's part A, which is 4 marks. Okay, so let's have a look at part B. In part B, we are going to do the binomial expansion. Let me just actually keep an eye on those answers. So A is equal to 0, B is 4, and C is 3. So A is 0, B is 4, and C is 3. So f of x actually becomes 0 over 3x plus 2, so that doesn't exist. 4 over 3x plus 2 all squared plus 3 over 1 minus x. So I'm going to rewrite it as 4, and then I'll write this bracket as 2 plus 3x to the power of minus 2, and this one 3 and 1 minus x to the power of minus 1. I'm going to use binomial expansion to expand these two up to the x squared term, and then collect together the like terms. So let's concentrate on this one over here. So 4 multiplied by 2 plus 3x to the power of minus 2. In order to use the binomial expansion formula, which looks like this, 1 plus x to the power of n is equal to 1 plus nx plus n times n minus 1 over 1 times 2 x squared, etc., etc. We only need to have the x squared term. So in order to use this, I need to have 1 in this bracket. So I need to take that 2 outside, okay? Now, as soon as you take it outside, so factorize it out, you need to give it this power, because that power affects everything in this bracket. And then you'll be dividing this by 2, so it's 1 plus 3 over 2x all squared. Now, if you pop this into the calculator, it will just do it with a calculator. That will give you 1, because it's 4 times a quarter. So really, we have to expand 1 plus 3 over 2x to the power of minus 2. So let's do it here. We're just replacing that x with 3 over 2x and n with minus 2. So it starts with 1. Then you've got this n times x. So it's minus 2 times whatever 1 is added to, 3 over 2x. Plus, then you've got minus 2 multiplied by minus 2 minus 1. Just subbing it into this. Over 1 times 2, and then you've got 3 over 2x squared. So let's just tidy it up really carefully. 1 minus, you'll have minus 2 times 3 over 2. That's minus 3x plus. Now this one here, on the calculator, you want to pop all of this and also 3 over 2 squared. There you go. So you have minus 2 times minus 3 over 2, and then it times 3 over 2 squared. So it should be 927 over 4 x squared, but double checking it. So let's put minus 2 multiplied by minus 2 minus 1, and on the bottom you've got 1 times 2, so just put 2 down, and then here you have to put 3 over 2, so 3, or put 1.5 if you prefer. Just make sure you put the correct one, squared. There you go. So it's 27 over 4. So now we're going to do the second expansion. Okay, so we need to find what 3 multiplied by y minus 1 minus x to the power minus 1 is. So it's 3. Now you need to reach the power of x, 2 with x, so it's 1. Then you've got plus n, so it's minus 1 times minus x, because that's x is 1 is minus x is added to 1, plus minus 1, then minus 1 minus 1 over 1 times 2, and then you've got minus x squared. So tidy it up, you get 3, 1, minus 1 times minus 1x is plus 1x, and then over here you will have minus, minus, and minus 1 squared, so it's positive 1 times 2 over 1 times 2, that will give me x squared. So multiply it by 3. And finally, we are clearly adding the two results. So adding them together, f of x gives us the answer of 1 plus 3, which is 4, minus 3 plus 3x, so 0x, and then 27 quarters at 3. Do it on the calculator. So 27 plus 12, 39 over 4x squared. So it's 4 plus 39 over 4x squared. Double check. 27 divided by 4 add 3. There you go, 39 over 4. So that gives me a part B. Now, if find the percentage error made in using the series expansion in B to estimate the value of 0.2. Give your answer to 3 significant figures. So I think it's f of 0.2. I think the picture is not. Let me just double check. Yeah, it's just f is on the end of the other line. Couldn't quite see it. So in part C, where they are telling you to substitute 0.2 into expansion. So that is using the expansion. So there you go. So it's 4 plus 39 over 4 multiplied by 0.2 squared. So this is 439 over 100, which is 4.39. So that's using expansion. And the true answer, we are going to use the original equation. So we are going to put this into the function 27x squared plus 32x plus 16 over 3x plus 2 all squared, and then 1 minus x. So using the true answer, 0.2 equals, and we're just going to substitute it into this expression, 27 ans squared plus 32 ans plus 16 over, in brackets, 3 ans plus 2 all squared, then 1 minus ans. There you go. That gives me 2935 over 676. Let's see how close this is to the real to that other answer. Not too bad. Okay. Now, what does it mean to find the percentage error? So it's percentage, in percentage, how far are you away from the correct answer using the binomial expansion? So we just need to find the difference. So for percentage error, we're going to use the difference over the true answer and then multiply it by 100%. So what is the difference between the estimate and the true answer? So it's going to be 439 over 100, that's the estimate, minus true answer, there you go, over the true answer, I could see that the estimate is bigger than the true answer because the true answer was 4.34. So the estimate represents overestimate, but they are not asking us to look at that. We just need to find what is the percentage difference. So we are going to do 4.39. So it's 4.39 minus this one, which is actually stored as my answer in the calculator, over the answer. So that will give me a decimal. Okay, multiply that by the 100%. So percentage, so it's 1.11% error. There you go. And that represents because the estimate was bigger than the true answer. That was the over estimate, just in case they ask. They are not asking in this question. Also, it gives you two significant figures, so it's 1.1.